Civilization is at a crossroads. The fork in the road in front of us leads to two very different destinations. One road leads to greatness and exaltation, and the other to oblivion. How do we know which road to navigate? In the fourth chapter of Hosea, the Old Testament prophet informs humanity that my people are destroyed for lack of knowledge. The question raised by this verse is what precisely comprises the knowledge that can potentially prevent our destruction? It signifies that ignorance, explicitly of wisdom, truth, and right living, leads to negative consequences, hardship, and ruin. At the root of the word ignorance, we find the meaning to ignore. In the present circumstances, it means ignoring the signs and the omens that are everywhere about us, attempting to command our attention. These portents of our time are seeking to deliver a clear-cut message from the cosmos to the world. Our future prosperity, if not our survival, depends upon us heeding this message and understanding its meaning. A central purpose of the Squaring of the Circle podcast is the deciphering and interpretation of this cosmic message, the message that will lead us back to knowledge and ultimately to wisdom. So join me in this episode of Squaring the Circle, and we will dive in to these compelling ideas. Hello, I'm Randall Carlson, and I'd like to welcome you to another episode of Squaring the Circle, where we're not afraid to challenge sacred cows, ask politically incorrect questions, and cut through the pervasive smog of propaganda polluting our environment to connect the dots that are being deliberately ignored by mainstream media. And in this quest for truth and authenticity, I'm going to be joined by my friend and colleague, Mike Howtube Robertson. And there he is.
And there he is. Hello, Randall.
Hello, Mike.
It's very nice to see you.
Yeah, how's everything out there in the state of Oregon?
Not too bad. We're getting our summer, our summer days are coming along pretty well.
Same here. Everything is green, filled out, and the last
Yes.
couple of days we had a pretty cool spring so far. We had a couple of muggy days. Now it's back to being rather cool again. And we've had some good rainfall. We were somewhat in a drought for a couple of months, but I think we've made up the deficit mostly over the last week. In fact, it was one of those rainstorms that came through the East Coast that got me stranded up in Newark.
Oh.
While the storm was passing over. And that's why I ended up sitting in an airplane for 7 hours that would normally be a 1 hour and 45-minute flight.
You mean just recently?
Yeah, I was in New York.
That's right.
And I did couple of podcasts. Mark Gagnon, not Paul, Mark Gagnon, and Julian Dury.
Julian Dory, yeah.
Dory. Yeah, really, I like both of those guys. They're both very astute. They get it. And it's always refreshing to see somebody of a younger generation than myself that gets it.
Nice.
And that's, for me, always sort of inspiring and makes me more optimistic that maybe we actually have a chance.
That's great.
Excuse me. So, anyways, I want to talk to you about, Mike. I know that we've had this conversation, and portions of this conversation have, of course, this is themes I've been dwelling on for years, if not decades, literally decades. And it's something that I always revisit, always update and upgrade my understanding of this phenomena. But what I'm referring to here is the fact that we, the human species on planet Earth, are waking up to the fact that we are part of a much larger cosmic ecosystem than that that we're familiar with here as dwellers on the surface of this planet Earth, right? And we have really become aware of the fact within the last few decades, actually going back, half a century, really, since we first established our beachhead in space, if you will, which was
Mm-hmm.
the late 1950s, early 1960s.
Mm-hmm.
And what we've learned since then is that, yes, it's Earth is part of a much larger ecosystem. And it's not at all like that ecosystem out there, the cosmic ecosystem and the terrestrial ecosystem don't interact and affect each other. The cosmic ecosystem most definitely affects in many multiple ways all conditions down here on the surface of the earth, organic and inorganic both.
Mm-hmm.
Interesting thing is that the terrestrial system in its own way feeds back into the cosmic system.
Mm-hmm.
We're not going to get into that so much in this episode. What we're going to be talking about is the imprints of the cosmos on the surface of the earth. And what
Mm-hmm.
is the primary vehicle for that? Well, it's the debris, the cosmic debris that we now know we cohabitate near space, of the inner solar system, with a tremendous, almost inconceivably huge population of material. And we're going to explore some of that because there's two takeaways of this. Number one, encounters with this material, this cosmic debris, could be profoundly destructive.
Mm-hmm.
Or, on the other hand, it could be something that provides us with a tremendous, incalculably valuable resource. So we're
That's
gonna.
that's a big statement right there.
Well, I'm sometimes known for making big statements. Um,
Well, I mean, what you mean by that is potentially mining asteroids and other cosmic bodies, that are floating around
I
out there.
like the word harvesting.
Okay. All right. Well, are we going to talk about that tonight? Or is that a little bit
No, we
later?
are going to talk about that, but
Okay.
first of all, we're going to start familiarizing ourselves with the denizens of the cosmic deep, the things, the beasts that we share the inner solar system with,
Okay.
because they're constantly traversing our neck of the woods and showing themselves to us, and we're beginning to learn every time another one comes through, and we observe it. We learn more about these creatures that occupy our space of the cosmic terrain.
Right.
So we're going to begin by talking about asteroids. Uh,
Okay.
you
And
mentioned the word.
there's something current too, and that
Oh yeah,
you've
we're
got your
we're
eye
coming.
on
Yes,
here.
yeah, and we're going to come around to that. So hang with us here while I introduce you to the cosmic beasts that are roaming the spaces between the planets and the sun.
Mm,
So
mm,
asteroids, a minor planet, an object that is neither a true planet nor a comet. So they're different. Although what we've learned and continue to learn is that there's no clear-cut dividing line between asteroids and comets. Comets can sometimes be composed of material objects that are basically indistinguishable from asteroids. That's what I'm trying to say. Now, a comet and an asteroid are two very different things, but a comet can be an aggregated mass, right? It's not a single homogeneous. It can be very heterogeneous.
mm,
And in
mm.
that conglomerate, there can be things that basically are virtually indistinguishable from asteroids. Devolatilized cometary nuclei are sometimes very challenging to differentiate from an asteroid. So it's neither a true planet nor a comet that orbits within the inner solar system. They are rocky, metallic, or icy bodies. Now, see, if you have an icy body right there, we're phasing into something that has more of the characteristics of a comet. Okay. With no atmosphere, obviously. Sizes and shapes of asteroids vary significantly, ranging from 1 meter 1 meter rocks, to a dwarf planet,
Mm,
almost 1,000 kilometers in diameter.
mm,
So we're talking here about something 600 miles,
mm.
1,000, easy conversion, 1,000 kilometers is roughly 600 miles. Okay, so I think what I am going to do is we will go right into share screen,
All
and
right.
we will we'll become familiar with the asteroids and the unfolding knowledge of asteroids and the discovery. So, do you know, Mike, when the first asteroid was discovered?
I do
I
not.
mean, I'm talking about modern science. I'm not, we'll leave the question open of what ancient people may have known or not known. But at least in terms of modern science, when was the first asteroid discovered? And what was it? What was it named?
It would have been in 1893.
Well, you're in the right century, but you're too late. Earlier than that. But you're in the right century. In fact, go almost all the way to the
All the
beginning.
way back, 1809.
New Year's Day, 1801.
1801. Wow.
On New
Okay.
Year's Day, it was the Ceres, Ceres, was the first asteroid discovered by Giuseppe Piazzi
Mm.
at the Palermo Observatory. It
It,
is 583 miles in diameter. So let's take a look here. We have some cool photographs of
okay.
Ceres. Share screen. Ah, there it is. Yeah. Now this one is very spherical. Now, a lot of asteroids are not even remotely spherical, but the Ceres is almost spherical.
Relieve body pains with plant medicine. Use the salve topically for sore muscles, aching joints, and stiffness. CBDfromthegods.com. Plant medicine that works on many levels. Formulated to penetrate deep into your muscles, tissues, and joints, it provides great relief. And try the CBD oil. Taken sublingually, it also relieves pain, but facilitates stress relief and neutralizes anxiety as well. When taken at night before bed, it provides the deepest night's sleep possible. CBDfromthegods.com.
Okay, then we'll go to the next one. The next asteroid. Now, okay, so at this point, New Year's Day, 1801, and for the rest of the year, 1801, and from there on, we humans knew about one asteroid out there, and a big one, considered by some, as it says, to be a dwarf planet. And then in 1802, the next year, the second asteroid was discovered, Pallas, by Heinrich Wilhelm Olbers. It's the third largest asteroid in the solar system with an average diameter of 318 miles. Now, you'll notice that it's a little bit more misshapen than Ceres, right? I'd say Ceres has a greater degree of sphericality. It may have to do with the fact that it's bigger and hence more massive, and therefore there's going to be more gravitational forces on the mass of the object, forcing it to want to uh, conform to the geometry of that requires the least expenditure of energy to maintain, and that's the sphere, right? Um, so you see that the smaller one here. Now this is speculation, of course, but if it was, assuming here, like if the density of these two objects is the same, then there won't be the same internal gravity forcing the material of this asteroid as with Ceres to try to compel that asteroid to assume a spherical shape. Does that make sense?
Yeah.
Okay,
Yeah.
good. Okay. Now we look at this one. Notice that its shape is very distended.
Mm-hmm.
It's the third asteroid discovered in September 1st, 1804. Notice here, right at the very dawn of the 19th century, we start having these asteroid discoveries,
Mm-hmm.
right? 1804 by Carl Ludwig Harding. It's the second largest asteroid in the solar system with a mean diameter of 157 miles. But it's quite misshapen, so it's too rigid and not massive enough that the gravitational attraction amongst the molecules composing this structure to cohere into a spherical shape. But this is actually just an artist's conception, as it says. But I imagine it's a pretty accurate depiction. And then we have Vesta. It's the fourth asteroid discovered March 29th, 1807, by Heinrich Wilhelm Olbers, the second one I guess he discovered. It's the second largest asteroid in the solar system with a mean diameter of 326 miles. As it says over here, the image was created July 24th. So this is an actual image. This is not an artist's depiction. By the Dawn spacecraft from a distance of 3,224 miles or 5,200 kilometers. And then we have a comparison of the first 10 asteroids to be discovered compared to the Earth's moon. And they're all to scale. As it says, the objects are left to right. Dwarf planets Ceres, you see that's the biggest one. Then 2, Pallas. 3 is Juno. 4 is Vesta. Astrea is 5. 6 is Hebe. 7, Iris. 8, Flora. 9, Metis. And 10 is Hygeia. So those are the first 10 asteroids to be discovered. And I don't know when was the last one of these. I don't have the year the last one of these discovered. But this gray circle represents the moon. Okay, let's just keep going here. So here's the evolving census. First asteroid discovered, Ceres, in 1801, and then we just went through the chronology of those discoveries. When we get to 1898, we see the first Eros asteroid, which is seen approaching the Earth. See, none of those other 5 are approaching the Earth. They're all in their own orbits, well outside the Earth, not approaching the Earth. So 1898, first asteroid seen approaching the Earth. Then in 1932, we have an Apollo asteroid, which was the first asteroid to cross Earth's orbit. See, so we go from completely outside the Earth's orbit, no interaction, to an asteroid seen approaching the Earth. Now to 1933, we see an asteroid crossing the Earth's pathway, Earth's orbit. By 1970, about 30 near-Earth objects, or NEOs, are known. See, so 1970. 1990, about 135 NEOs, near-Earth objects, are known. And then we get to the turn of the century and the turn of the millennium, there's at least 400 NEOs known by the end of the century. And these are near-Earth objects, right? Well, now we see here the current estimated number of near-Earth objects larger than 1 kilometer in diameter, 1,500.
Okay. So does that mean that our technology got better and we can detect more?
Oh, yeah.
Or does that mean it's increased?
No. We're detecting. We're seeing more.
Yeah.
We have technological eyes and abilities now that our grandparents didn't have, our great-grandparents that didn't exist. Now, there were certainly telescopes, but, in order to discover an asteroid, you have to be looking at space at the right time when the asteroid is in that spot. You can't do wide scan surveys of the heavens to see things that are moving, right? Which we can do now. You look at the backdrop of the fixed stars, and you take a recording of that, and then you take a recording of it the next day, and it looks exactly the same. Well, nothing's happening there. But if you look and there's a point of light like a star, but then you take another snapshot somewhat later, and it's moved, well, now you've got something there, and it's probably going to be an asteroid because a comet usually shows the tail. Okay. Let's go on here. All right. So this is some of the recent discoveries. Look at this guy, Bennu. It's an example of a carbonaceous asteroid discovered on the 11th of September, 1999, with an equatorial radius of 926 feet. So that's pretty darn big. Now, 926 feet, let us recall that the asteroid that struck Arizona and gouged out the big crater, I say big crater, it's little, relatively speaking, but the crater that's a kilometer wide and 600 feet deep, that was excavated by an iron asteroid striking the Earth, and it was between 100 and 150 feet, roughly, in diameter.
Wow. That
So what would a
definitely
926 foot?
Yeah, that puts it in perspective for sure.
Yeah. There's asteroid Eros, long axis dimension 21 miles. Now, if something like that struck the Earth, yeah, we would be extinct. It wouldn't be just a civilization. We would be extinct.
Wow.
The only way humans would survive is if we were able to relocate off planet temporarily.
What about underground?
Well, maybe, but you have to understand that something that large striking the Earth, you're going to have seismic activity, volcanic activity. You're going to have large pressure pulses passing through the entire planet. I mean, the entire tectonic framework of the planet is going to be shaken. It's possible. Yeah, I would guess, but I don't know how you would know where. I mean, obviously, if you're in the epicenter of the impact, this is going to utterly, completely wipe out something the size of America. You know, the huge, well, look at, I mean, the 6 Mile asteroid that took out the dinosaurs struck, you know, whose crater is now buried in the under the Yucatan Peninsula, was 6 miles in diameter. And yeah, I mean, it's likely that every fault line on Earth failed as a result of that impact. And look what it did. It exterminated, you know, 3/4 of all species, terrestrial and marine, on Earth. Now, what would an object that was 3 times the size of the KT boundary impactor? Well, that's going to be one hell of a disaster. That's what I'm saying. I mean, we wouldn't survive.
That's a planet buster.
That's a planet buster. Life would survive.
Sure.
But I don't know how advanced that life would be. I mean, we know that, you know, extremophiles would undoubtedly survive, you know, particularly in other, you know, outside the zone of total destruction, you know, radiating outward from the impact point.
Yeah.
Asteroid Ida with its moon Dactyl. That's kind of cool. An asteroid with its own moon.
That's interesting.
Discovered September 29th, 1884. It was the second asteroid visited by a spacecraft, and first to have its own moon that we know of. Long axis, look at this, 59.8 kilometers or 37 miles. Wow. But there's no danger of this size right now striking the Earth anytime in the near future, because we are, you know, we're identifying and mapping the orbits of these objects, and they're not in any danger of striking the Earth. However, that doesn't mean that we're, you know, out of the woods. That doesn't mean that, oh, well, we don't have to worry about impacts, as we're going to see here. Okay. Because there are many degrees. An object this size, of course, this is going to be a planet killer.
Yeah.
You know, and the thing of it is the bigger you get, the more rare become the objects within that size range. As you come down the scale, though, what you lose in the individual mass of a really large asteroid like this one, you gain in numbers. You see, so there's lots more small asteroids than there are asteroids of this size. I mean, we're looking at, you know, some of the biggest asteroids, and that we know of, none of the asteroids this size are in any potential possibility of impacting the Earth anytime in the near future, ever. I'll say thousands and thousands of years ahead, we don't see any possibility of an impact. Now, something coming out of the blue, see, like we'd have to be looking at something like, the recent interstellar visitors that came through, the intergalactic things. Those are the things that could just come out of the clear blue, but there, the Earth compared to the vastness of space is a very, 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 very small target. And the chances of something flying into the inner solar system from outside the solar system and colliding with the Earth are really, really close to zero. But
Okay.
stuff that's inside the solar system, that's a different story altogether. Let's keep moving here. And here's asteroid 25143 Itokawa, discovered September 26, 1998. It's an example of a rubble pile asteroid, 1,100 feet, long axis. Now that, you see, is not a single object. What you got there is a bunch of conglomerates stuck together by gravity, and it's all, and probably something else too. There's probably some kind of cementitious stuff in there. We can see these smooth areas, which look like really fine grained. But yeah, it's like a glued together massive conglomerate of stuff. It's not like you take one, like imagine an asteroid and you think, oh, a trans-Martian planet explodes and you've got all of these chunks of the planet. Well, if we took, so this is 1,100 feet long. If we went in and we took a sample of an 1,100 foot long mass of Earth's bedrock, I mean, there might be different types of rock. The petrology might be quite diverse, but it would still be one rock. This is a bunch of stuff that's basically stuck together. So it's a rubble pile asteroid. And there can be rubble pile comets as well. And so you can see here that we're looking at something where we might be grading into this transitional phase between, obviously comets on one end of the spectrum and asteroids on the other. Vesta, discovered March 29th, 1807. I think we already saw this one, but yeah, this is a good one because it shows the sphericality. Asteroid Psyche, this is an artist's depiction, discovered March 17th, 1852. It's a metal-rich asteroid, which is very significant, as we'll come back to. Mean diameter, 140 miles.
That asteroid looks like it's been hit by a couple of other asteroids, doesn't it?
That's right. That's right. And it's in that the tremendous heat and energy and pressure released during those impacts that could be responsible for catalyzing the formation of precious metals. Okay, then we've talked so much about Tunguska. We're not through talking about it, but Mike, the object in Tunguska, 1908, June 30th, 1908. We've discussed that. We've discussed it in the context of our Halloween presentation. It's probably where we discussed it in more detail than anywhere else. Why? Because the Taurid meteors peak right during Halloween. The few days leading up to and the few days after Halloween is the peak of the Taurid meteor shower. And we've made the argument that the celebration, the recognition of Halloween, which was very universal in the ancient world, you remember all of this, right? Was probably because people were experiencing the Taurid meteor shower, which is known to astronomers to have been much more active in the past than it is now. But we know that object that descended down and exploded over Siberia was maybe 140, 150 feet in diameter. And we know that it utterly decimated over 800 square miles or over 2,000 square kilometers of dense old growth taiga forest right up just south of the tree line, the latitudinal tree line. And we know that around a couple of hundred square miles, right at the epicenter, underneath where this blast occurred, and let's be clear, it was an atmospheric blast, not a ground impact. Okay.
Mm.
Very important to keep that in mind. The difference between an atmospheric burst and a ground impact. Atmospheric bursts can actually have a larger radius of destruction because there's nothing to contain the shock moving outwards. It's just free to move through the atmosphere, and that's what blew down. It was the pressure pulse that blew down the 800 square miles of trees, and it was the fire plume that came down. The thing blew up roughly 5 miles up in the atmosphere. The plume of fire that came down and intersected the earth incinerated a couple of hundred square miles of the forest directly under the epicenter of the blast. Outside of that incinerated areas, you find all of the trees splayed outwards because the pressure pulse came down, hit the earth, and spread laterally, and then knocked the trees down. So that's what we know from 1908. We were given a cosmic lesson, if you will, in 1908. The human species was shown what the cosmos was capable of. So there was an impact, an atmospheric impact, though. Let's be clear on that.
Mm-hmm.
And as a result, we also know, because just a few years before 1908, seismometers were placed that were able to register the fact that there was like a 5.5 or 5.6 earthquake accompanying the atmospheric blast. And barographs had been in use in Britain for just a few years that measured the pressure pulse moving around the planet as a result of that explosion. Of course, at the time, nobody knew what it was. Nobody knew what caused this pulse of pressure to pass over Britain twice within 11 hours. Well, it was the blast wave, think of it that way, the shock wave moving out, encompassing the entire planet. And then it deposited some type of volatile substances in the atmosphere, which caused all over Europe the nights to be extremely light, almost like dusk, for days afterwards. So, anyways, we're going to talk about 2001 YB5, which is an asteroid that's come very close to the Earth. It's come so close that it's worth contemplating what the consequences would have been had that thing impacted the Earth. And it was big enough that it would not have disrupted, it would not have detonated in the atmosphere, it would have most definitely struck the ground. Okay, so here's the size of the Tunguska object, and then we'll put 2001 YB5 next to it.
Oh my God.
To try to get a sense of, what kind of damage would this do? Well, this would, something this size could take out an area the size of Texas.
I'll say.
Yeah, even more. All right, so here's now the different families or classes of asteroids. And it's good to know this if you're going to try to understand this, what these creatures are that we cohabit space with. All right, so the Amors are Earth approaching near Earth asteroids with orbits exterior to Earth's but interior to Mars. Okay, so the Amors do not cross Earth's orbit, so we don't really have to worry about the Amors causing collisions. Okay, you'll notice here A, which is the basically the distance is 1.0 astronomical units, and 1.07 astronomical units less than Q, less than 1.3. So what this is showing us here is that A is greater than 1 astronomical unit. And what is an astronomical unit? It's the distance of the sun to the Earth. So if it's greater than that, that's what's showing here. Here's Earth's orbit, right? Well, here's the orbit of an Amor. It's completely outside the Earth, the Earth's orbit. So there's no danger of collision. So you'll notice that Q, now these are just have to do with the orbital elements. We don't need to necessarily get into what they are, but it's going to fall between 1.017 astronomical units and 1.3. Okay. Then you have the Apollos. They're Earth crossing near Earth asteroids. They have a semi-major axis larger than Earth's, named after the asteroid 1862, which we already referenced, the Apollo. And here, as you can see, 1.0 astronomical units, which is the semi-major axis of the ellipse. So the semi-major axis is, if you take, let's go back up to the Amors. You see this is an ellipse, not a circle. Okay, if you draw a line from the farthest point, the widest diameter of this ellipse is going to be the major axis, and half of that is going to be the semi-major axis. Then you're going to have the minor axis, which is the shortest axis. Now you can picture that if you draw axes in here, like you draw from the shortest axis, and then as you rotate that axis around until you get to the longest distance, that's your major axis, and half of that is your semi-major axis. Q is the aphelion distance. What does that mean? Well, that's the farthest away that it gets from the sun. So you can see here that both of these are greater than Earth's orbit. Okay. Well, what that means is it's not going to cross Earth's orbit. But look at here. Your Apollo, your A, which is your semi-major axis, can be right at 1 astronomical unit. In other words, its orbit can be the same distance from the sun as the Earth's. And Q, the perihelion distance, which is the closest to the sun that it gets, is going to be less than 1.017 astronomical units. So Apollos are essentially crossing our highway. Look at the Atens or A10s. They're Earth crossing near Earth asteroids with semi-major axes smaller than the Earth's. Right? Look at this thing here, semi-major axes. So check this out. From the object out here, so you go to the middle of this, and you take half of that, it's less than the distance. You see how most of this A10 orbit is inside the Earth?
Within our orbit, yeah, I see that.
So A, your semi-major axis is less than an astronomical unit. And again, the astronomical unit simply represents the distance between the Earth and the sun. So if it's less than 1 AU, that means it's inside the Earth's orbit. Okay. And it could potentially cross the Earth's orbit, right? And then you have the Atiris, I'm not sure how to pronounce that, but their orbits are contained entirely within the orbit of the Earth. So, but again, you see, they don't cross. Just like the Amors out here, they don't cross Earth's orbit. The Atiras don't cross the Earth's orbit. They're inside. But the Apollos and the A10s cross the Earth's orbit. So I call this Close Encounters While Mankind Sleeps. Okay, so my interest in close encounters with the denizens of the deep, the creatures that live in the inner solar system along with us, really began in earnest in 1988 when there was a near miss. And then again, another one in 1989, another near miss. And I had already known about the theory of the dinosaurs being exterminated by an asteroid impact. So I was already well aware of that and very interested in the whole phenomenon of asteroid impacts, right? And what role they played in Earth history. Well, then mostly I was preoccupied with thinking about past impacts and the ongoing discoveries of impact craters and astrobleeds, the scars of those impacts, and what influence they may have had on where they connected with mass extinctions, like the KT impact, were they associated with climate change or anything that we could discern in the record, the geological record, that would show some kind of a disruption. I was not really thinking too much about the context of what's going on at the present, other than as I learned more about Tunguska, particularly really studying it in the 80s. I certainly knew about Tunguska early in my researches, but I think I really started looking it into the 80s. By the early 90s, I had, one of the things that happened early 90s is after the Cold War ended, we had access, American scientists got access to a lot more Soviet Russian science. And a lot of that, they had studies. A lot of those studies, of course, were focused on the Tunguska event of 1908. So post early 1990s, there was a slew of new research that American scientists had access to. So that really accelerated my interest in the Tunguska phenomena. Anyhow, as a result of that, I was certainly aware of the idea of things from space impacting the Earth. But then with these two back-to-back close encounters in 1988 and 89, I began to really start monitoring. And over the next few years, I was quite stunned, shocked even, at how frequently these close encounters were happening. And then I also realized that, well, not too long ago, close encounters could happen and we wouldn't even know it. Right? So then the question became, in my mind, the same question you asked earlier. Well, are we seeing more things encroaching upon Earth-occupied space, or are we just seeing more? Well, I think I'm inclined to think we're just, we have technological capabilities now we didn't have when I was a kid growing up, that didn't have when my parents or grandparents were around. So we've got technological enhancement to our ability to see what's going on in near Earth space. And this is what we're going to be, or what we are talking about here. So let's just get into some of it. Now, this was before, these are scans that I did directly from newspapers and so on. This was before internet, right? So I wasn't able to go and look stuff up online. But this was one that really impressed me. Back March 22nd, 1989, asteroids passing a close call for Earth, NASA says. So this is Asclepius 4581. It was discovered March 31st, 1989. Let's see. No, we've got to disconnect. These dates might be gotten inversed. Let's see. So if this is March 22nd, it obviously had been discovered by this. So, but March of 1989, that's the important takeaway here.
Yep.
It passed Earth. Okay. Got it. Okay. So here's what's going on. It passed the Earth on March 22nd, but it was not discovered until March 31st.
I see.
After it had already passed.
Got it.
So then we're able to see, oh, geez, look at this. This thing came by, a week earlier, and we didn't even know it, right? In cosmic terms, it was a close call. A large asteroid capable of wreaking widespread damage in a collision with Earth passed within 500,000 miles last month, the closest approach of such an object in 50 years, astronomers said Wednesday. The asteroid, a collection of rock and dust 0.5 mile or more in diameter, crossed Earth's orbit undetected March 23rd, at a distance equal to twice that between Earth and the Moon. Scientists later calculated that the asteroid, traveling at 46,000 miles per hour, is orbiting the sun once a year on an elliptical path that regularly brings it back toward Earth. Now, if this thing is, what did it say? How big was it? 0.5 mile or more in diameter. 0.5 mile impact is now right at the threshold at which the consequences become global. 0.5 mile in diameter, we're looking at global consequences. We're probably looking at a collapse of the global food supply. Because the fires and the dust injected into the atmosphere would take 3 to 5 years to pretty much clear out. And during that time, we could have some extreme cold weather. So Henry Holt, the Northern Arizona University astrogeologist and astronomer who discovered the object in photographs, it can come closer. It can come this closer in the future, he said. Now, you might look at this and go, oh, it was moving at 46,000 miles per hour, but it was 500,000 miles away, roughly twice the distance of the moon. So nothing to worry about, no matter for concern. Okay, we'll see how that holds up, that assumption. But imagine the metaphor that I might use here to try to put this in some kind of a context, comprehensible context would be, let's say you decide to go hiking somewhere, say in Alaska, and you're hiking along. Doesn't matter. You could put yourself in any environment on Earth. You're going to have certain things that could be threatening, that could be dangerous. You know that if you're going to go into explore the Brazilian jungles, the Brazilian rainforest, you need to be well prepared, don't you?
Mm-hmm.
You need to be apprised of what those dangers might be. Now, let's suppose you're sleeping in your tent at night and you hear the growl of a jaguar off in the distance. Or you're hiking up in the woods of northern Minnesota or out in Wyoming or Montana or Canada, and you happen to look out and you see a grizzly bear, down by the creek, and he's a mile away, and you go, oh, well, I don't need to worry about the grizzly. I don't even need to think about grizzly bears because we see that one guy and he's far away. But that wouldn't be the prudent approach, would it? The prudent approach is that, there's grizzly bears in this environment, so I need to be alert to the fact that, this time of year, maybe they're going to be hungry. So the fact that you see that grizzly bear and he's a mile or 2 miles away and is not any immediate threat doesn't mean that there's no significance to that bear. You realize that, okay, I'm in an environment right now where such creatures exist, right? Now, let's say you continue on your hike and a few hours later, you happen to see another grizzly bear, only instead of 200 yards away, he's only 150 yards away. And you're thinking, oh gosh, there's another one. There's a lot of these bears here. And you could use any metaphor. You're swimming in the ocean and you see a shark.
Mm-hmm.
And, this shark isn't that big. I don't think he's going to bother me. But every once in a while, there are shark attacks by big, mean, vicious sharks. And I think you get the metaphor. It's like, okay,
Absolutely.
So we look out into space and we see, oh, well, we thought there was nobody there, but there's somebody or something there. Now, 500,000 miles away, well, that's twice the distance of the moon, so no need for worry, okay? Well, that might not be the prudent response. Let's go on. Bevan French, a scientist with the National Aeronautics and Space Administration, said that if an asteroid this size hit the Earth, the impact would be equivalent to the explosion of 20,000 1-megaton hydrogen bombs.
Wow.
That's beyond nuclear war.
Yeah.
This is, yeah. Dr. French, an expert on large space objects in NASA's Solar System Exploration Division, said in an interview that such an impact would create a crater 5 to 10 miles wide and perhaps a mile deep. Landing in the ocean, quoting him now, could be even more destructive, he said, depending upon the depth of the water, angle of entry, and size and speed of the object. It could create huge waves several hundred meters wide. Waves that large could sweep over coastal areas, causing widespread destruction. Now, let's see, what did he say? Several hundred. Well, if you're looking at 200 meters, then you're looking at 656 feet. And we can see the evidence of a tsunami on Madagascar that was over 600 feet when it made landfall. We can see that, and we can look at the deposits left behind, and we can look at the elevation of those deposits above sea level. And we know that those deposits were placed there by a tsunami wave. So experts say the Earth's geological record shows evidence of more than 100 large objects hitting the planet. This is 1989. Now we know of at least 200. So it's doubled. The number of actual impact scars identified on the Earth has doubled since this report in 1989. Collisions with large objects are suspected of causing dramatic disturbances in the solar system, although there is no evidence of planets being knocked out of orbit. Scientists believe that less massive objects hitting a planet could tip the planet's axis of rotation, but the asteroid observed last month is too small to cause such disturbances. We don't even need to discuss that really because, again, the rarity of an impacting object large enough to cause a tip in the Earth's axis of orientation is virtually nil. So, a widely discussed theory supported by geochemical evidence and sediments worldwide holds that an asteroid or comet about 6 miles in diameter struck Earth 65 million years ago. So this was this article in the newspaper. See, I saved it. I cut it out and saved it. This is scanned from that. So this is kind of what really triggered my interest in close encounters. So, and I was quite impressed by the idea that this thing swung by and we didn't see it until whatever, 8-9 days later. Okay, let's keep going here. And then, okay, so now this is March 22nd, then August 25th, just a few months later. Giant asteroid makes close pass by Earth. A mile-wide chunk of space rock slipped within 2.5 million miles of Earth on Thursday, the second nearest approach of a large asteroid this year. People living on the Earth are in no danger from it, said Brian Marsden of the International Astronomical Unit's Central Bureau in Cambridge, Massachusetts. It's just a nice approach, which makes it very convenient for astronomers who want to study it. So now let's look at some of the specifics of this. It's asteroid 1989 PB Castalia, a potentially hazardous asteroid of the Apollo group, right? It is 0.87 miles in diameter, or 4,600 feet. It passed within 2.5 million miles from Earth on August 25th, only 14 days after its discovery. And just for reference, it's 28,700 times more massive than the Tunguska cosmic object. Now, again, you can say, well, 2.5 million miles, that's plenty far away. But here, just a few months apart, we're looking out there into our neighborhood and we're seeing, wow, there's this stuff moving out there and it's big. And it's moving at 40 and 50,000 miles an hour. Well, okay, so far we're 1.5 million, 2.5 million miles away, no matter for concern. We don't have to be concerned because this stuff is, this big stuff that could cause planetary catastrophe, it's too far away, all right? Okay, let's keep going here. We're going to jump ahead to 1991 a little bit. A near miss of the Earth by a small asteroid. Okay, asteroid 1991 BA, 30 feet. So closest to Earth, 105,000, I think this was kilometers. So it's very close. It's very close, but it's little. You can say, oh, okay, well, 30 feet. Now, if a 30-foot object came in, it would explode in the atmosphere probably, or if it was a lower density, if it was a high-density iron object, it would strike the Earth. Certainly not going to create a planetary catastrophe. You probably wouldn't want to be within 200 or 300 or 400 feet of the impact. If it was lower density, it could explode in the atmosphere and create a hell of a cool light show, right? And you would feel the shock wave from it. You would, it would create atmospheric phenomena. It would create acoustical phenomena that would be very impressive. But it's just a little one, but it came very close to the Earth. Okay. Then we got January 18, 1991. In this report, we have a near-miss asteroid revealed as two bodies. And this object was discovered on August 9th. Let me see. Yeah. So this is January 18th, and then this is August 9th. It's 4,900 feet in diameter, approximately. It was 2.5 million miles. Okay.
Okay.
So we're seeing that there's stuff out there, and it's big stuff. I'm not trying to include everything here, just a sort of a cross-sectional sample. May 19th, 1996, all eyes on near-miss asteroid. 1996 JA1 is a very small asteroid. Oh, it says very small. Okay, well, that's comforting, isn't it? Whose orbit crosses the orbit of the Earth. NASA JPL has classified 1996 JA1 as a potentially hazardous asteroid due to its predicted close passes with Earth. Discovered May 14th, only 5 days before close passage. Now, notice this. JA1 is 700 feet in diameter. Energy released upon, so it's 100 times larger than the Tunguska.
Gosh.
If this thing had struck, it would release energy about 1,500 megatons. So given that the largest nuclear weapon ever tested by the U.S. was 15 megatons, which is about the same as the Tunguska. I think this could be actually, because Tunguska was about 15 megatons, which is equivalent to the largest hydrogen bombs the U.S. military tested in the 1950s and 60s, right? So this is 100 times more powerful than that. 100 times. And it's 100, assuming...
It's hard to imagine.
Yeah. So just think of that. Okay, so if Tunguska could devastate 800 square miles of forest, if we go 100 times that, that's 80,000 square miles. That's going to be severely affected by this object. Notice they're calling this a very small asteroid. Well, only 700 feet in diameter.
Yeah.
100 times larger than the Tunguska object. Let's see, from the newspaper article, it was a close call for planet Earth. Last weekend, a piece of space rock the size of Fayetteville's Cross Creek Mall, that's I'm sure what you were thinking, right, came within 279,000 miles of Earth. It was so faint in the night sky, it took a minimum of a 4-inch telescope to see, and then you had to know exactly where to look. So here's the thing. 279,000. Okay, the other ones we were looking at 1.5 to 2.5 million. If we say 2,500,000 miles, then this is 279,000. What we're seeing here, okay, is that this is like 1/90th of the distance of the, so this is a whole lot closer.
A whole lot closer.
A whole lot closer. So now we see an object that's large enough to cause extreme damage and probably have climatic consequences that could last for several years, in addition to completely wiping out a huge area. What's a state in the U.S. that's roughly 80,000 square miles, 70 to 80,000 square miles?
Arizona.
Is that Arizona about that size? Yeah, ask AI. What state is close to 80,000 square miles?
So they come up with Utah.
At how many square miles?
84,898. Okay. And then the closest one to 80,000 even is Kansas at 82,276.
So there we go. An object this much in 700 feet in diameter, impact velocity at 40,000 miles per hour. We're looking at an area the size of Kansas, completely destroyed. Now, that is not the perimeter. That's not the edge of the radius of destruction.
No, it's
You're going to probably
be,
have, yes. Okay.
Yeah, not to mention the consequences of the environment and the aftermath and all that stuff.
Right,
Yeah.
right.
Yeah.
So let's keep going. August 10th, 1998. Asteroid 1998, ML14. Now, this one really caught my attention. It was discovered on June 24th, 1998. Its closest passage to Earth was 1,674,000 miles. Okay, well, that's a comfortable distance, right? But that's not the whole story. Asteroid 1998 ML14 is a stony asteroid classified as a near-Earth object of the Apollo group and a potentially hazardous asteroid. Approximately 1 kilometer in diameter, discovered June 24th, 1998 by linear survey. Okay, but here's the crux of the issue. At midnight, Greenwich Mean Time on August 10th, 1998, ML14 crossed the orbit of the Earth at the exact point that the latter had occupied 18 hours earlier. Had ML14 reached that point at 6 a.m. the previous morning, an area the size of France would have been totally devastated by 6:05. Most of the world's vegetation would have been in flames by 8 o'clock, and 30 to 40% of the human race would have been dead or dying by late October.
Oh, wow.
See?
Deep breath. That's a near miss.
Yeah. Here's a new study published in June of 2000. A new study estimates that 900 large asteroids cruise orbital superhighways where they someday might strike Earth, causing widespread death and destruction. Yet so far, astronomers have found only 40% of the big space rocks, each at least 0.6 miles or 1 kilometer wide. Now, what happens? Now, 0.6 miles, but what happens if 1,000-foot asteroid, which is much smaller, 0.6 miles, let's see, so 5,280 times 0.6, 3,168 feet. Now, imagine a smaller object, 500 to 1,000 feet, striking the Earth. That's a huge calamity. That's a huge calamity, right? And it would most likely have devastating consequences in the immediate aftermath of the entire global economy, if nothing else. And the amount of destruction rendered over a significant portion of the planetary surface would require an amazing amount of mobilization of resources to restore it. You're going to have a lunar landscape covering thousands of square miles. So what do? Do you abandon it? Do you go back and re-inhabit it? This raises a lot of questions, but let's go on. October 24, 2000, here's what was appearing obvious by that time, that the asteroid estimates were too low.
Oh, wow.
9 objects have come close to the Earth since 1991. 9 objects. Current predictions for the number of potentially dangerous asteroids have been underestimated by at least 20%, say astronomers. According to recent calculations, there are between 750 and 900 asteroids circling the Earth with the potential to cause devastation on impact. But a researcher at the U.S.-based Massachusetts Institute of Technology says these predictions should be revised upwards on the basis of new data. December 22nd, we had an asteroid making close approach. Astronomers have tracked a large asteroid moving close to Earth. The 45-meter wide or 150-foot space rock traveling at more than 18 miles per second. Think about that, 18 miles per second, 1,001. In that span of time, it's moved 18 miles. It came within 480,000 or 300,000 miles of the planet. Although this is close in astronomical terms, there was no danger of an impact. No, there wasn't, of course. I mean, at 300,000 miles. But 300,000 miles, again, that's a lot closer than 1.5 or 2.5 million miles. And notice, this is in the same ballpark of size as both the Tunguska object and the Arizona meteorite. Think of those both in the range of 140 to 150 feet in diameter.
Okay.
This was estimated to be 150 feet. So this is a Tunguska-sized object zipping by. May 7th, 2001, a group of scientists is seeking a standardized protocol for dealing with the possibility of an asteroid or comet striking the Earth, saying humans can do more than the dinosaurs ever could before a colossal impact precipitated their extinction 65 million years ago. So it's in the news now that by the turn of the century, a lot of scientists are going, yeah, this is a real hazard. And maybe these things are rare. But the problem is that a cosmic encounter could be so extremely devastating, even a small one, that we really need to be cognizant of just how much of a threat these things really are. Asteroids worry some scientists. This is just an elaboration of the same report. This call comes as interest grows in the swarm of asteroids and comets that orbit the sun in Earth's immediate neighborhood. The concerns were sparked in part by several recent false alarms about impending impacts. Thank God they were false alarms. Said Daniel D. Durda, a research scientist at the Southwest Research Institute in Boulder, Colorado, quote, "In some sense, it's something we know we need to worry about, but we need to decide at what level we need to worry about it." And that's a question for everybody. In recent weeks, a paper written by Durda and fellow scientists Clark R. Chapman and Robert E. Gold has been making the rounds among experts who study impact hazards. The goal, they write in the 19-page paper, is to encourage discussion of how to replace the haphazard and unbalanced way the world now addresses any potential impact. Now, here we are 26 years later, 25 years later, quarter century later, and I'm afraid to report that the world's approach to this particular issue is still haphazard and unbalanced. In fact, if we want to segue off for a minute into geopolitics, we're busy creating crises where none exist, while real crises continue to unveil themselves.
Do you mean by like fighting amongst ourselves and all the senseless?
Exactly.
Yeah.
Or imagining that a small incremental increase in carbon dioxide is going to trigger a climatic catastrophe. So this was the paper that came out, the Comet Asteroid Impact Hazard, a Systems Approach, came out in February of 2001. Paper worth reading, and I think it's open source, so we could actually provide a link to this paper if anybody wants to download it and read it, because it's still timely. Okay, January 7, 2002, a huge asteroid nearly misses Earth, almost as if to punctuate the appearance of this report. In intergalactic terms, it was a close shave. An asteroid capable of causing widespread devastation narrowly missed the Earth on Monday, although the nearest the asteroid came to Earth was 390,000 miles. Had it arrived 4 hours earlier on its journey around the sun, it would have scored a direct hit. So here we have another one now. The asteroid, measuring 300 meters or 984 feet across and known as 2001 YB5, passed Earth at 7:37 a.m. For a moment, it was less than twice as far from Earth as is the moon. Now, go back to the graphic I showed you of the Tunguska-sized object. That was YB5 that you saw next to it.
Okay.
So here again, it crossed Earth's orbit. And 4 hours later, Earth passed that exact point.
That is crazy.
It is. And who knows? I don't hear anybody talking about this.
Yeah.
I don't hear anybody up in the, maybe now NASA, yeah, there are NASA scientists.
Well, they probably don't want to just freak people out by, they got to keep the herd calm.
Well, then it's our job to make the herd nervous and pay attention. Scientists were unaware of its approach until a month ago. Right, this would have been the end of 2001 when it was spotted by an American observatory dedicated to tracking near-Earth objects. Astronomers insisted there was never any danger of a collision with Earth, but they warned that the asteroid was one of up to 400,000 small NEOs up to 1,000 meters or 3,280 feet wide that could strike Earth with little or no warning because of the absence of an adequate early warning system. Think of it, up to 400,000. Wait a second. This has come a long way from the early discoveries of asteroids in the early 1800s, right?
Yeah.
And then we've got, January 7th, large asteroid passes close to the Earth. Had it been on a collision course, it would have created one of the worst disasters in human history. No, I think we could say it would have been the worst disaster in human history. Sorry about that. That's about 300 times larger than the Tunguska cosmic object. An impact of an object the size of 2001 YB5 would unleash energy roughly equivalent to a global nuclear war. It could be classed as a civilization killer.
Mm-hmm.
March 8th, 2002, asteroid buzzes Earth, highlighting cosmic blind spot. An asteroid large enough to have flattened a city buzzed Earth earlier this month and was not seen until after it flew harmlessly by. The space rock approached Earth in the glare of the sun, a blind spot that made it impossible to see during the day or night from any terrestrial vantage point. The event illustrates the potential of a surprise hit by an asteroid, astronomers said. The object, now named 2002 EM7, was probably between 40 and 80 meters, or up to the small end of that range. It puts it roughly about the Tunguska size.
Mm-hmm.
The large, at least we could figure it out, multiple times greater than.
Like 80%.
Yeah, because with a roughly spherical object, the volume scales as the third power of the radius. So up to 260 feet in orbital velocity, 69,000 miles per hour. It was 1 to 5 times larger than the Tunguska cosmic object. Energy released equivalent to Tsar Bomba. Tsar Bomba was the largest nuclear bomb ever tested by the U.S., by the Americans, by the human species. It was detonated, I believe it was 1962, by the Soviet Union, and it was estimated to be 50 megatons. Now, the Tunguska explosion is estimated to be 15 megatons. So this is like more than 3 times the power, one hydrogen bomb. So this object, energy could have been in that ballpark. Tsar Bomba.
For the audience, you're going to want to turn your volume up for this.
Yeah. If you've got a widescreen, watch it on the widescreen, turn your volume way up, and check this out. Here we go. So by looking at a video like this of Tsar Bomba and getting a sense of what 50 megatons, the kind of energy released, here's the thing to keep in mind. When we're looking at 50 megatons, we're looking at the largest human-caused explosion in all of history. Yet that's relatively on the low end of cosmic explosions, right? Of impact-generated explosions. That's the low end. So, we saw Chelyabinsk, what was it, February of 2013 or 14, I think it was 13. Had that been a little bit bigger, that could have been a Hiroshima-sized explosion relative to the town of Chelyabinsk. A little bit bigger. As it was, 1,500 people went to the hospital. It caused a lot of surface damage, but it was something like 18 miles up in the atmosphere when it exploded, and it was really small. It was only a fraction of the size of Tunguska. A Tunguska evidence would have completely wiped out the city of Chelyabinsk.
Of course.
And if a Tunguska-sized object exploded over a densely inhabited area of anywhere in the world, any big urban area, the east coast of the United States, you can expect that there'd probably be 1 million people instantly killed from a Tunguska size, just as you could imagine a 15 megaton nuclear bomb. Now, the largest hydrogen bombs in the U.S. arsenal were about 15 megatons. Now, they generally weren't incorporated into the warheads of intercontinental ballistic missiles. Those were much smaller, especially once military strategy, nuclear strategy went to multiple warheads, where you would put up to 9 or 10 individual warheads in a single bus that goes on top of the rocket for delivery. There, I think, less than a megaton was the norm. But a lot of the early ICBMs had warheads that were in the range of a megaton. So the argument could be made, really, that 50 1 megaton explosions would be more devastating than 50 megaton.
You could probably cover a broader area.
You could saturate a broader area with
kill more people, etc. Yeah.
Yeah.
When you think of it in those terms as like a rational person, it's like, why are we even doing that? Why do we create that stuff? I don't want to get too philosophical here, but
that's a question, Mike, that we will address. We need to understand the mentality, the psychology that prevailed in the world post-World War II, and why we deployed atomic bombs against Japan when it was not a military necessity. And virtually none of the military leaders believed that it was going to be necessary to prevent the invasion of the Japanese homeland that was planned for December. Pretty much the consensus opinion was that Japan would not be able to hold out from August to December, that they would collapse. The decision, and anybody can research this history for themselves, the decision to deploy the 2 atomic bombs against civilian targets in Japan was a civilian decision and not a military decision. And that's important. But maybe, just maybe, in the extreme irony, perhaps it was the horror unleashed by the destructions of Hiroshima and Nagasaki and the human effects that it had, both in the immediate environment of the explosion and in the aftermath. I think that horror that we saw, that we were able to witness, perhaps was one of the reasons why those weapons have never been deployed in war since.
Well,
so in a sense, it's perhaps the Japanese civilian loss of life, their sacrifice, perhaps, played an important role in why, in the conflicts that we engaged in, like the Korean War or the Vietnam War, some of those, neither side deployed nuclear weapons, because the horror of what could happen with the nuclear weapons. By the time we get to the Korean Wars of the early 50s, we now have hydrogen bombs, the super bomb. By the time we get to Vietnam, absolutely, we've got a whole arsenal of thousands of deliverable nuclear bombs, right? We're in the era of mutual assured destruction.
Mm-hmm.
Now, luckily, there was enough cool heads in the superpowers, America and Soviet Unions, that nobody wanted to take the risk that was being presented to the human race by the presence of these bombs without it being unregulated, uncontrolled. And so you had a whole series starting in 1972 of treaties and agreements that both sides came to and agreed upon through a whole bunch of mutual meetings. And we're going to talk about this history because it's critically important. But as a result of that, whether the SALT Treaty, the START Treaty, the ATM, the Limited Test Ban Treaty, and more, those treaties helped us to prevent Cold War that was over 40 years in duration turning into a hot war with nuclear weapons. Now, guess what? All of those treaties have been abandoned, and mostly by the American side. At the same time, we are planning to launch a new arms race because we have this 10-year plan. It actually started in the Obama administration to completely revamp and upgrade our whole nuclear weapon systems, our nuclear strategy, and our nuclear doctrines. The Russians have essentially followed suit. And so there are no more agreements. They've been completely abrogated, abandoned. Trump himself has played a big part in that, right? So people need to be aware of where we're going here with this. You know, we were lucky. There were more than one time when we almost came to a hot war with Russia, with the Soviet Union. We were lucky. And we had some people, at least in power, who I may have disagreed with them a lot of times. I may have not thought so highly of some of these people. When you go back, we'll talk about some of these people who are the architects of our nuclear doctrine, particularly the MAD, the mutual assured destruction. But the point is we managed to avoid a hot war. And a big part of how we avoided that hot war was through this series of constant negotiations and creating these agreements and these treaties and so on. None of that exists anymore. It's all been done away with. And virtually nobody gets it. You see what this means, what this implies for our future. But we need to try to wake people up and inform them that, look, we were lucky the first time. We survived over 40 years of Cold War. There's no guarantee that we're going to survive another Cold War and another arms race. In fact, I would put the odds no better than 50-50 that if we pursue this policy of global domination and of a whole new generation of nuclear weapons, unrestrained by any kind of mutual agreements between us and the Chinese, us and the Russians, and so on, our chances are of not going into a hot war in which nuclear weapons could be used are going to be getting more and more probable that this is going to be the outcome. And so I'm hoping that a lot of young people are listening to this and understanding that we want a future. And this was what I was saying at the beginning in the opening comments about we now stand at the crossroads. And one side leads to greatness and exaltation, and the other side leads to oblivion. And that's literally where we stand right now. And we have a bunch of leaders that, compared to the leaders of 40 and 50 and 60 years ago, are really stupid. And we're going to put the fate of our civilization in the hands of these people who narcissistic megalomaniacs and power-hungry hegemonists. No, I don't think we want to do that long term. Anyways, let's circle back to what I think to be a real threat
Let me
life
ask.
on Earth.
Let me
Yeah,
ask
yeah.
one question. I can't remember the size of the. You mentioned 2 of the near misses that crossed our orbit. There was 2 of them in like 2001, 2000.
Yeah.
What size were those again, and how would that compare to the video we saw?
Oh,
Just to create context.
much
So
bigger. Much bigger
there
than
was one of those 2 that you mentioned missed us by what, 18 hours or less.
well, let's
In,
see. Yeah, that was
and you can put it back up if you want, but I'm just curious because that once you saw that video, and then you can compare it to a meteor strike where we weren't so lucky and we didn't miss it, of a size that you had mentioned in those previous examples.
okay, so I was talking about 2001 YB5.
Okay.
Okay, approximately 1,000 feet in diameter, which is about 300 times larger than the Tunguska cosmic object.
Okay.
So an impact of an object the size of 2001 YB5 would unleash energy roughly equivalent to a global nuclear war.
A
It would
global nuclear war.
a global nuclear
How
war.
many megatons do you think?
Well, let's see. I think we can. Let's see. Well, we could easily let's just use volume to get an approximate idea. So, or the energy release. So, 300 times larger than the Tunguska.
And Tunguska was 15 megatons.
Yeah, so we could go 15 times 300, and that would be 4,500 megatons.
There you go. That's what I was. And
Yeah,
what we
so
saw in the video was 50, give or take, just
yeah,
over 50.
yeah. So that'd
So
be a total. Divide that by 50. That would be about the unleashing of energy about 90 times Sarbamba.
that
Yeah,
puts it in perspective.
that puts it in perspective. That's asteroid 2001 YB5.
And
1,000
that
feet.
and that missed by hours.
Yeah.
It missed our orbit by, I can't remember exactly, but I think it was somewhere between 12 and 18 hours.
Yeah. And let's see
So
what was right. Okay, so let's continue on here. Let's see. We saw that asteroid buzzes Earth, highlighting cosmic blind spot, and that's where we left it because that was up to 260 feet in diameter.
okay.
Which would put it, if that was the larger end, that would put it about 5 times the mass of Tunguska.
Okay.
So then that puts it up. That was where we left. That puts it up. Tunguska being 15 megatons, and that times 5 then would be 75 megatons. Okay. And if that could be overstating, I don't know, but easily, I think conservatively, we could put it in the ballpark that it would be an explosion about the energy of Sarbamba. Okay, and that was March 8th, 2002. Actually, let's see. Yeah, March 18th, March 8th. It was discovered March 12th. That's why they say it's highlighting the cosmic blind spot. So it was moving at the leisurely pace of 69,000 miles per hour.
Leisurely pace.
And it was just a little bit outside the orbit of the moon.
Oh, wow.
And then on June 14th, so we're jumping forward from March 8th, 2002, then the following June, we find this: too close for comfort. Asteroid passes within 75,000 miles of Earth. So that's way inside the orbit of the moon. So that's, yeah, let's see here. That's, I'm in the dark here. Yeah, that's way inside the orbit of the moon. The orbit of the moon is about 250,000 miles, 250,000, right? So divide that by 75,000. Let's go back to 70. Check my work here. 1, 2, 3. I think I'm in order. Let's see, 250,000 miles to the moon, and if I divide that by 75,000, yeah, about 33. So if you took the distance from Earth to the moon, this was less than 1/30th of the distance from the Earth to the moon. And it was about 240 feet in diameter. So that's about 4 times larger than the Tunguska. So its energy release, again, would have been about that equivalent of Sarbamba.
Okay.
And that came only 75,000 miles from the Earth. Much less than a third the distance to the moon.
So why do you think this haphazard approach to focusing on this, spending energy and scientific minds focused on it, and why does that haphazard approach continue? Or could it be said, like with DART, maybe there's increased focus on it a little bit to a degree, but still, I think you said earlier, the haphazard approach to all of this just continues to this day. And if that, like, why don't we focus on it more?
Well, that's a good question. That's a real good question, and we should be focusing on it more, and that's why I think we're making the case, a very strong case, that we should be focusing on it more. Why not? Well, because we've got other priorities. For example, fighting a war in Iran, fighting a war in Ukraine, deploying our military, in dozens and dozens of places around the world. The climate change silliness. We're in the middle of a climate crisis because we've increased the amount of carbon dioxide in the atmosphere by 1 molecule for every 10,000 molecules of air. That's, and you've got millions of young people who think that the real crisis facing humanity is a slight increase in a life essential gas into the atmosphere.
Carbon dioxide.
What?
Carbon dioxide.
Carbon dioxide, yeah. Oh, we're in the middle of a climate crisis, say the people over and over and over again who know nothing about climatology or paleoclimatology. And all they can do to support their assertions and their claims is, 97% of scientists agree. Oh, they do? What do they agree on? Tell me exactly, what do they agree on? Tell me, what is the effect, the atmospheric effect, the temperature effect of a small fraction of 1% of an increase in carbon dioxide? And they can't tell me. Well, who are the names of these scientists that are all in agreement? Well, the same people, whether they're politicians or, Democrats, are going to be the most susceptible. Environmentalists, for the most part, they don't know. And they have no comprehension of the long-term story of climate on Earth, because they just don't, because that's not part of the discussion.
Yeah.
Because if you looked at the history of climate on Earth and you realized how severely and how frequently it has changed, to much greater degree than anything we've seen in the last 150 years, you'd realize that, wait a minute, there's a whole lot of unanswered questions concerning climate change.
Yeah.
And we're definitely going to take a dive into that. That's what I'm saying. I mean, we're going to challenge some of these sacred cows.
Yeah.
And we're going to ask politically incorrect questions. And we're going to connect dots that mainstream media doesn't want to connect. Because what would happen is it would undermine the existing hierarchy of power, political power, which has been built. It's a whole house of cards that's been built upon all of this stuff, whether it's the climate. See, if you've got young people who are hysterical over the climate crisis, well, they're not looking at what we were just talking about.
Right.
The fact that we are entering a new arms race, a new nuclear arms race. That's a 1,000 times more more disturbing than the slight increase in carbon dioxide.
Yeah.
And we'll have that. We're going to have that conversation for sure.
That's the real threat.
Well, and then the other real threat. So we can look at the two real threats. One is anthropogenic, and it's not burning fossil fuels and carbon dioxide. It's nuclear proliferation and potentially perpetual war for control of the planet's resources. And make no mistake, that's what our whole foreign policy is about, the control of planetary resources. All right. The other is natural. And that's what we're talking about in this episode. We're talking about one that's outside
Sure.
the control of human beings for the present, and is actually, we're seeing in its own way, is as dangerous and destructive as a nuclear war. Okay.
Yeah.
So,
and nobody will tell you what these dangers are, except for this podcast.
yeah. So here, coming forward now to August 17th of 2002.
Do you mean to be sharing right now or no?
I think we should share.
Okay.
That was just crossing my mind. And you were apparently reading my mind.
Yes.
As you do. Okay. All right. August 17, 2002, a near miss. Asteroid whizzes past Earth. Stargazers got their telescopes and binoculars ready over the weekend, trying to spot an asteroid which came closer to the Earth than any space rock of its size in 77 years. The 800-meter wide asteroid whizzed over North American skies late Saturday, missing the planet by about 530,000 kilometers, slightly farther away than the moon, but still a near miss by astronomers' standards. Now, it's part of the Apollo group. Diameter, I think the final diameter ended up being 2,624 feet, about 5,000 times larger than Tunguska, with an explosive yield on impact of approximately 80,000 megatons. So this is even way, way beyond nuclear war. An impact of an object this size would be globally devastating, definitely a civilization killer. And then, 2003, in September, we have the closest asteroid yet, flies by Earth. An asteroid about the size of a small house, so this is not going to be causing a global
destruction,
but it's going to cause a hell of a light show to anybody witnessing it. And some pretty amazing sonic booms and acoustical phenomena, but it would not be locally devastating. But it's just another. It was because it was the closest approach of a natural object ever recorded. So it passed 88,000 kilometers from the Earth. And let's see, 88,000 kilometers is, let's see, time divided by 1 equals times 0.6. That'd be about 52,000 miles. Geostationary communication satellites circle the Earth 42,000 kilometers from the planet's center. The asteroid designated 2003 SQ-222 came from inside the Earth's orbit and was only spotted after it had whizzed by. So many of these, you notice, are discovered only after they've flown by already.
Yeah, I noticed that, yeah.
Right? Earth almost put on impact alert. Now we're in 2004. Astronomers have revealed how they came within minutes of alerting the world to a potential asteroid strike last month. Some scientists believe on the 13th of January that a 30-meter object, later designated 2004 AS1, had a 1 in 4 chance of hitting the planet within 36 hours.
Wow.
Now, that didn't happen. I mean, it was later they revised it, and the margin of safety was considerably greater. But for a while, because what happens, you make a discovery, you have to refine those orbital parameters. right, through a period of prolonged observation and measuring. So then when you do that, well, you're going to, you're going to come up, well, maybe it's not as dangerous as we thought, or it's more dangerous. In this case, it was not, it was a lower probability of striking the Earth. But as we see here, near misses raise rocky questions. Asteroid 2004 AS1, approximately 500 meters or 1,640 feet diameter. January 14th could have been a bad day for George Bush, as the president was preparing to announce America's return to the moon. Well, look how long this took after that, right?
Mm-hmm.
In a speech at NASA headquarters, he was almost asked to deliver a very different message, that the Earth could be struck by a devastating asteroid within 24 hours. Astronomers have revealed that during a 9-hour crisis the night before Mr. Bush's speech, they believed there was a 1 in 4 chance an asteroid would hit the planet in 36 hours. Had it not been for a break in the clouds that allowed an amateur astronomer to give the all clear, the scientists say they were on the verge of calling the White House. Now, again, what this is just a wake-up call. All right?
Right.
Their time, it very realistically could come where, yeah, we see an impending impact, and then it does make landfall. March 19th, 2004, asteroid soars past Earth oh so closely. Pasadena, California, 100-foot diameter asteroid passed close to Earth harmlessly by Earth on Thursday, astronomers said, only 26,500 miles above the southern Atlantic Ocean. It was the closest recorded encounter between Earth and an asteroid, said Stephen Chesley, an astronomer at NASA's Jet Propulsion Laboratory, right? So 100-foot in diameter, that's roughly between the Chelyabinsk and Tunguska. Okay. Asteroid 2004 MN4, a really near miss. If you expect to be alive on April 13th, 2029, you can look forward to an asteroid watching party across 3 continents like nothing the world has ever seen. And we are now, 3 years? We're just past, we're now less than 3 years from a really close encounter with a really big asteroid. And this is kind of what can happen to asteroids, is that one asteroid can break up into something like this, and could see an Earth encountering something like this would be like a shotgun blast.
Sure.
Yeah. And this, in my mind, is the real danger, because we couldn't deflect something like this. Like the DART mission, which was the asteroid redirection test.
Right.
That basically was one object. We showed we can deflect one object, yes. What do we do in the case of a swarm? See, we're not there yet. And swarms are very real. We're going to talk about that. January 29th, 2008, asteroid 2007 TU-24, estimated diameter 250 meters, 829 feet. Was only about 1.4 times the lunar distance. So this is, large asteroid zooms past Earth. Then we go from January to March of the next year. Asteroid 2009 DD45, discovered February 27th, 2009, only 3 days before close passage. Mean diameter, 23 meters. Okay, so that again puts it in the range roughly between Chelyabinsk and Tunguska. Not a global catastrophe, but if it was to explode over a populated area, you could have hundreds or even a few thousand fatalities. Right? Again, we had 1,500 injuries from Chelyabinsk, but we didn't have any fatalities that I know of.
Okay.
Tunguska, we didn't have any fatalities, but if a 15 megaton explosion occurred over a populated area,
Oh, yeah.
you're going to have tens of thousands of casualties conservatively. But it says here, this space ball measured between 69 feet and 154 feet. So 150 feet, that puts it right up in the size range of Tunguska and the Arizona iron asteroid. So if it's in that range, yeah, now we're looking at a megaton explosion. If that's the size. Now here it's a smaller estimate, but sometimes it varies. Now this is suggesting 69 feet to 154 feet, which is larger than this one. Then we have asteroid 2005, YU55, discovered December 28, 2005, at a distance of 201,000 miles inside the orbit of the moon, basically 1,400 feet in diameter, about 800 times larger by volume than the Tunguska. So you can go 800 times larger. That's a 15 megaton times 800. And we're looking at 12,000 megatons,
God.
which was greater than the entire nuclear arsenal of America and the Soviet Union during the peak of the arms race. So, yeah, then we have September 7, 2014, newfound asteroid will give Earth super close shave on Sunday. Only 24,800 miles of from Earth's surface, 50 to 82 feet in diameter. So that's about the size of the Chelyabinsk asteroid, which is estimated at 60 feet. If 2014 RC was closer to 82 feet, it would be approximately 32% larger than Chelyabinsk. And now you're talking about, we're getting into some fairly severe surface destruction and probably some fatalities. Near miss, October 10, 2015, giant asteroid 2 miles wide, traveling at 40,000 miles per hour, zooms past Earth. Earth had a lucky escape this weekend. Okay, it was 25 million miles away, so it was really far away. But again, we look out there and we see that now 25 million miles, that's well within the cosmic neighborhood of the Earth, right? That, using that analogy of the grizzly bear in the distance, what this is showing us is, yeah, there's some really big stuff out there too. 2 miles. You realize, what we're getting into there now. We're getting up to...
That's a civilization killer.
Oh, it's a civilization killer, and it's also a mass extinction creator. Yeah, there's going to be species that don't survive. A 6-mile object destroyed 3/4 of all terrestrial and marine species on Earth when it collided. This wouldn't destroy that many, but I can guarantee you there would be major mass extinctions. Civilization, of course, yeah, that's without debate, that's gone. Then the question is, what does it do to the biosphere? How many species are going to not be able to survive this? Then we get to October 31st, 2015. Halloween asteroid resembling a skull narrowly misses Earth. And look, we can see down here, discovered October 10th, 2015, 2,130 feet in diameter, distance at close passage just outside the orbit of the moon, 2,800 times larger than the Tunguska object. A nearly 3-mile wide asteroid makes a relatively close call with Earth. It was 4.4 million miles away, but that's a hell of a lot closer than 25 million miles, right? So basically 6 times closer, almost. So here's 3 miles. That's 1,175,600 times larger than the Tunguska object. We could keep going with this, right? Asteroid 2014 JO25, discovered May 5th, 2014. Rolling and tumbling, buzzworthy space rocks. Asteroid hunters prep for near miss. Only 50 feet in diameter, so it's a hell of a light show. but no massive. Yep. Then we got a large asteroid just zipped between Earth and the moon. It was 330 feet, so that's a city killer. Asteroid surprise close approach illustrates need for more eyes on the sky. NASA asteroid tracker, 328-foot near-Earth object to zip past Earth on Friday. We're up to 2019. It's 100 meters or 328 feet in diameter. That is definitely easily a big city killer.
Mm-hmm.
Asteroid watch. Now we're coming up here to Aiton group. This is 2020 now. 4 near-Earth objects to pass by in June. Near-Earth asteroid 2020 GH2, very close encounter. There's an image of it, approximately 100 feet in diameter. So again, that's getting up to the city killer size. NASA tracking giant 750-foot asteroid traveling at 62,000 miles per hour near Earth's orbit. Radar views show big asteroid 1998 OR2 tumbling in space ahead of Earth flyby. Its diameter is a mile. Tiny asteroid. So this is a 20-foot. Again, this is a light show. A newly discovered asteroid will pass close to Earth on Thursday. This asteroid just skimmed Earth's atmosphere, 30 to 36 feet. They're little ones, but you can see they're just coming one after another. Record number of asteroids seen whizzing past Earth in 2020. Despite pandemic disruptions, astronomers detected thousands of previously unknown near-Earth asteroids last year. A blue whale-sized asteroid to screech past Earth in close encounter on June 6th. This was in 2022. A 200-foot asteroid, 2023 DZ2, passed closer than the moon. 200 feet. Now, 210 feet, that is about eight times greater in volume than the Tunguska. So again, using our just broad ballpark, if we go 15 megatons times 8, we're looking at 120 megatons, more than twice the power of 2 Tsar bombas. And that came closer than the fucking moon. Okay? Watch house-sized asteroid, 2023 MU2, fly by Earth at over 2,000 miles per hour. And we have this one. Asteroid the size of 35 chickens to pass Earth on Sunday. At 25 meters in diameter, it's around the size of over 35 chickens. Not just a couple of dozen chickens, but over 35 chickens. Roughly the size of Chelyabinsk meteor. So this is now one of the new scientific standards for estimating the size of near-Earth asteroids is in terms of how many chickens. Okay. July 16th, time to start praying. Potentially hazardous asteroid to pass by Earth on Sunday, a stadium-sized asteroid. 2023 MG6 has a diameter of approximately 2,071 meters, roughly the size of a stadium, and will swing by our neck of the woods at 23 hours, 37 minutes South African times, 44,564 kilometers per hour. It's plenty far away. But again, over and over and over again. Near-miss asteroid in the urgency of asteroid deflection. Can we stop them in time? What astronomers learned from a near-Earth asteroid they never saw coming. This one was about close to almost 200 feet, 2.3 times larger than the Tunguska object. It was only a quarter the distance from the moon.
Wow.
So that's very, very close.
Very close.
Newly discovered asteroid larger than the Great Pyramid of Giza will zoom between Earth and the moon on Saturday. That's 2024 MK. Again, it poses no risk. But how many are there going to be that fly by that don't pose a risk until the one that does pose a risk. NASA's planetary radar tracks 2 large asteroid close approaches. So we have 2011 UL-21 and, it was only 43,000 times larger than the Tunguska object. Is that right? Let's see. Where is the... Could be a typo. It couldn't be that big. Oh, it's a diameter a mile. Okay, then yeah. Yeah, if it's a mile. Okay, and the other one only has just a tiny one, a diameter of 500 feet, which is about 37 times larger than Tunguska. So that times 37 means that we're looking at about 555 megatons. And given that our large warheads during the peak of the Cold War and ICBMs were about 1 megaton or less, you could figure what would it be like unleashing 555 nuclear-tipped ICBMs. That's what we're talking about here. How many potentially dangerous asteroids narrowly miss Earth each year? Last year, now this is 2023, last year Earth had more than 100 close encounters with large asteroids. What are the odds of a direct hit in the near future? Well, that's what's constantly being recalculated. Then I make a note down here that the more we learn about our cosmic environment, the more we must reconsider and reevaluate the probabilities of a hypervelocity impact event, potentially with regional and or global consequences. Now, MN4, which is Apophis. Okay, this is the thing that's coming up. What astronomers now find alarming is that MN4, now appropriately dubbed Apophis, will be passing so close to Earth that our gravitational pull may affect the asteroid's orbital path, making its return flyby in 2036 unpredictable. Much like the proposed and bureaucratically stalled Indian Ocean tsunami early warning system that would have saved untold thousands of lives, astronomers in near-Earth object research face the same lack of pre-disaster support despite growing and ample evidence. One reason is that the authorities have a tough enough time balancing budgets without extending taxpayer funds to hunt for long odds objects in space, no matter how short those odds seem to get. Does it get much shorter than 5 minutes? That's how close we're coming to impact in 2029.
Well, we could easily afford it if we would stop wasting money on senseless wars.
Oh, you better believe it. Absolutely. Of course we could afford it.
Yeah.
Because we are wasting trillions on really stupid concocted wars that serve nobody except a few small elites. And in the long run, if these wars turn hot, even them, they're screwed. It's just unbelievably stupid what's going on. And we can only conclude that some of our so-called leaders essentially are demented. They've lost their minds. 4 minutes, 46 seconds. Not even enough time for a shower. The difference between life and death for millions on July 13th, 2029. The closing velocity of an incoming asteroid is about 12.6 kilometers per second. And if it were to cross the Earth's orbit, a near-miss distance in thousands of kilometers would translate into a mere few minutes from impact. The 2004 MN4 could have caused a catastrophe that would make the Asian tsunami seem like a walk in the park. This isn't pie-in-the-sky doomsday-type speculation, but documented scientific fact. As tracking proceeded, the figures have fluctuated slightly, and the closest astronomers predicted the asteroid 2004 MN4 would pass our planet is by a mere 3,380 kilometers or 0.53 Earth radii, the worst case inner edge of the predicted ellipse, or in more frightening terms, only under 5 minutes away. So this is what we're looking forward to on July 23rd, 2029. Now the question is, it's going to miss, just barely. But you remember what happened with Shoemaker Levy 9? The orbit coming that close to the Earth could be altered. And it could be altered in such a way that its next trip around, which would be in 2036, could be an impact.
Could be an impact, yeah.
Could be an impact. Now, this is real. This isn't some science fiction woo-woo fantasy. And, of course, there'll be a bunch of dumbasses and smarmy comments about, they're the same type of stuff that they say, right? And then, of course, you'll have the climate change cult, which will be, this is going to be distracting us from the real crisis, which is carbon dioxide enhancement of the atmosphere. And if you recall that movie that came out, a couple of years ago with, what's his name, the actor, environmentalist, and it was about a comet going to hit the Earth.
The Leonardo DiCaprio?
Yeah, and nobody's paying attention.
Yeah.
But what that was supposed to be was a here's that film was like the ultimate irony. Because what they're doing is, okay, there's going to be a potential comet impact on Earth and nobody's paying attention. They're just, completely obsessed with their day-to-day whatever, right?
Mm-hmm.
And that was supposed to be a metaphor for people not paying attention to the climate crisis induced by carbon dioxide. But what they really did was served up a scenario where, it just so happens that the real threat to Earth and the Earth's biosphere and the Earth's climate actually is something coming from space. So, anyways, I'm thinking we should leave it there for now, and we'll pick up another episode following on this, because here's the question. Okay, so we've had all these near misses. Well, if we look at history, do we see that evidence that there was more actual impacts in the past than we previously imagined? And the answer at this point is almost certainly yes.
Yeah.
Yes. And could those impacts of cosmic objects have affected previous civilizations? And the answer is absolutely yes. And in fact, we could show what I believe is the record from ancient civilizations all over the world, using their own symbology and imagery to document cosmically driven catastrophes. Mm. So we'll leave it there. Friday the 13th, 2029. Keep that in mind, because it's, coming up 3 years away. We're going to have a close encounter, and the whole world will be able to witness this thing zipping by the Earth. And then we'll see what happens in the aftermath. Does its orbital trajectory get altered?
Right.
Raising the probabilities of a greater probability of an impact in 2036 when it comes back again.
Right. By chance, do you want to show that all known asteroids video before we exit, or you want to save that one?
No, let's go ahead and show it.
Okay.
So I'm going to stop sharing so you can show this, because what this video does, it's released by NASA. And what it shows, I think it goes back, about 20 years, when we'd already discovered several thousand asteroids in near-Earth space. And go to full screen with that. And then what this is going to show is starting January 1999 and ending in 2018. So it's conservative, because we know about more asteroids now than we knew about in 2018. But this will certainly convey the impression that we live in a cosmic jungle with a big population. Let's watch it. So first we're going to have January 1st, 1999, known near-Earth asteroids. And we're looking down on the solar system, and that brightest blue orbit is the Earth. And now we're in 2009. Look at what's happening, 2018. Now I think we're going to get an oblique view so you can really see now. There we go. Yeah, here we go. So we've got thousands and thousands of asteroids occupying near-Earth space. Remember, January 1st, 1801, one asteroid was known. We've come a long way, baby. Now, go back to the still. We got out of that. I wish we had paused it. bef-
Okay.
um,
Hold on.
because
Go ahead.
one
Go
of the
ahead.
well, pull it back up. All right. So this is what our celestial neighborhood looks like now. Actually, from 2018. So there's even more. Okay. Now this presents the human race with a real challenge. We're seeing evidence. We're building the case that celestial cosmic impacts are potentially far more of a very real threat than mainstream is recognizing or wanting to acknowledge. And not only does it have extreme implications for our own future, it also has relevance to our own historical past on this planet. And that's what we're going to be looking at uh, in the next Squaring the Circle episode. And I would like to point out that what we're looking at here in this recurring video is that these thousands upon thousands of asteroids that we co-inhabit near Earth space are not only a threat to our planet, but they are also potentially resources on a scale that we can't even begin to imagine. And if we're going to survive as a civilization, I think that one of the prerequisites is that we expand into space, and part of the new space economy is going to be harvesting this almost infinite resources of our celestial neighborhood in the terms of what we see right here. And that will be a part of the upcoming conversation. And that could actually provide us with a realistic alternative to Armageddon and World War III, fighting over the limited and diminishing resources of our planet, our home planet. But that's going to require a cooperative enterprise. And we'll talk about that. And how do we build awareness of this potentialities that lie before us, this crossroads that we now stand on, that we now find ourselves at this crossroads with two very distinct destinations at the end of each one. I know without any doubt where I come down on the outcome I would like to see happen.
Mm-hmm.
But somehow we have to jolt humanity awake. We have to wake up and understand what the circumstances in which we find ourselves. And once we do that, I think it'll become clear that the choices before us are obvious. There's not, well, let's see, which one, this one or that one. No, there's not. Once you become aware of it and you take the side of life, then the road that we need to take becomes obvious. And I think from the cosmos we came, and ultimately life came from the cosmos, and the life will return to the cosmos. And I think that's maybe in the larger cosmic scheme of things, that's the function of a planet like Earth.
Right.
Is that microbial life can be seeded and it can evolve into something that can sit here now and expand our awareness of the world that we inhabit. And the world that we inhabit includes what we're seeing right here. And I think that it's time for us to start thinking about the human species harvesting this incredible resource that we see displayed right here.
Well, that'll be a very interesting conversation to discuss what the new space economy actually looks like. There's talk about it already.
Oh, yeah.
In different aspects of our society, of our government, and even in the business community. There's rumblings like starting, but it is a wonderful thought to think about an endless, almost infinite number of amount of resources that, with focus and with, some sort of a shared agreement towards a goal, a single goal, like we did when we went to the moon. Remember how the world came together when especially the United States, but the rest of the world was with us.
You mean
There
during
was,
the Apollo days or during
yeah,
the more
yeah,
recent? Yeah,
yeah, during the
okay.
Apollo days. It was just, I'm just referring to, the
Well, part of
everyone was behind it.
yeah, well, all of America was behind it.
Yes, for sure.
Certainly. Now, the Russians, not so much,
not
because
so
we
much.
beat them in the race.
They were probably the exclusion to my point, but the rest of the world, though, they were cheering on.
Oh yeah,
it on.
and interestingly, the Soviet Union was the catalyst for the space race when they put up Sputnik in 1958.
Very much so.
Now, friendly competition, absolutely, that's a good thing,
Mm-hmm.
but not to the point where it becomes a war, right?
Yes, and
but ultimately, the intelligent way to go about this is, yeah, friendly competition, but ultimately it's an international cooperative effort,
right,
to begin to establish the beachhead of a cosmic civilization off Earth. And we can argue about the role that humans would play out in space, and I think there is a role for that. But at this point now, we can definitely do a lot of it robotically.
Mm-hmm.
We can send robots out. We don't have to necessarily send asteroid miners.
Mm-hmm.
But again, that's something that it's an industry that's just in its infancy.
Right.
And, I think that we'll talk about that more. The whole idea of harvesting the resources, both material and energy resources, of the cosmic neighborhood outside our terrestrial atmosphere, outside the Earth. And I do believe wholeheartedly that's the direction we need to go.
Okay.
All right. So on that note, I think we'll call it a wrap on this one, and we'll be coming back to you with another episode where we follow up on this. And then we're going to sort of bring these two streams together because, please follow our Younger Dryas series that we're putting out, because we're going to try to put out the definitive presentation on the Younger Dryas, the controversies, the discoveries, the advancements in our thinking, and ultimately leading to the realization that the Younger Dryas is almost certainly the consequence of a series of impacts around 12,800 to 12,900 years ago. So these two discussions are going to converge at that point.
Nice. Okay.
All right, Mike.
All right. That was a humdinger.
Ooh, that was a long one.
Yeah.
By the time you edit it down, it might be a couple hours.
Yeah.
I think. Yeah. So that you got your long episode you wanted, Mike.